Hello scholars! Today we're going to be exploring arrays a little bit more because arrays are not something that you might just catch on to right away. We might need a little bit more practice. For those of you that felt really good about it yesterday, please challenge yourself to also write a multiplication equation to go with each array. Let me do a couple of examples for you first before you try on your own. We're starting with this one up here with the little bears. It says complete each missing part, describing each array. So we're looking to fill in all of these blanks. To describe the array means basically to count the array or to tell about what it's like. So we're telling about what it has in its rows, that means side to side, and its columns going up and down. So this is 5 rows of, it wants me to find, when I see the word of, it wants me to find how many are inside of each row. So I think row, okay, side to side, this is a row. That's 1, 2, 3, 3 bears. In this row, there's 1, 2, 3, 3 bears, right? So there are 1, 2, 3, 4, 5 rows, but they have inside of them 1, 2, 3 bears. So it's 5 rows of 3. And then it has an equal sign, which means it wants me to tell them how many bears are in the whole array. Okay, so this would be 3, 6, 9, 12, 15. I like using my multiplication songs to help me solve for how many are in each array. You can also just think of it as 3 plus 3 plus 3 plus 3. Well, I better make sure it's at the end of each row that I'm writing the 3 plus 3. So that's what it's asking for down here. What kind of a repeated addition equation can you use to find how many are in this whole array? Okay, you could do 3 and 3 makes 6. 3 and 3 makes 6. 6 plus 6 makes 12. Plus you're left with this 3 out here. 12, 13, 14, 15 makes 15. Okay, now this is the same kind of thing. When we saw 5 groups of 3, this is 5 groups of 3. It's just written with the words rows of instead. So remember, the word groups of is what multiplication is all about. So if we see 5 rows of 3, we're thinking 5 times 3. Because really, you have the number 5 3 times, 1, 2, 3, or you have the number 3 5 times, 1, 2, 3, 4, 5. Okay? So your multiplication sentence is going to look a lot like this sentence right here. 5 rows of 3 is 15 bears. Okay? So I'm going to do one more example on here. 3 columns. 1, 2, 3 columns of, better count inside. That was 5. 3 columns of 5. That would be 5 plus 5 plus 5. And I can count by 5s. 5, 10, 15. These make the same array. Well, no, it's not the same array, but they have the same number of objects in each one. This one was 15 bears, and this one was 15 bears. Okay? They're actually organized in the same exact way, so it is the same array. Okay? Oh, my goodness, silly Mrs. Charrington. Yep, it's the same exact array. I just labeled it in different ways. In this one, I was counting the rows, and in this one, I was counting the columns. But they both have 15 bears inside of them. You see, you can count it in 2 different ways. Okay? And your multiplication sentence could be 3 times 5. 3 columns of, groups of 5. 3 5s is still 15. All right, we're going to flip over to the back because this makes it a little bit more challenging. Okay, we'll do the example on the bottom because that's the most challenging one. Use the array of squares to answer the questions below. Okay, so first it just has a number sentence. An equation, 1, 2, 3, 4, 5. That might mean it wants me to add up all of those columns. 1, 2, 3, 4, 5. How many are in each column? 1, 2, 3, 4, 5. So it must be 5 plus 5 plus 5 plus 5 plus 5. Okay, and I can count these by fives. 5, 10, 15, 20, 25. There should be 25 squares in this whole array. That is how many rows? Okay, so I didn't count the rows last time. I counted the columns. I need to go side to side. 1, 2, 3, 4, 5. 5 rows of, and then I count inside of the row. So I'm looking at this row. 1, 2, 3, 4, 5. 5 is, and I know it's 25 because I just added it up here with my repeated addition equation. Then columns. How many columns? 1, 2, 3, 4, 5. 5 columns of, in each column there's 1, 2, 3, 4, 5. 5 columns of 5 is 25. Now it asks me to remove one row. Remove means to take away one row. How many squares are there now? So if I take this, oh, that's not a row. It said take away a row. I better be careful. Take away one row. Rows go side to side, so I'm going to take away this bottom row. Goodbye. Okay, how many squares are there now? Well, I know that that's just 5 plus 5 more, plus 5 more, plus 5 more. So 5, 10, 15, 20. Now there are 20 squares. Remove one column from the new array you made in 3D. So D, 3D. In this problem, I made a different array. It only had 20 squares in it because I got rid of that row. So now I need to remove one column from this new array I made up here. So let me remove one column. That means take it away. Columns go up and down. Goodbye to you, column. Okay. How many squares are there now? So now I have to count what's in here without counting the squares that I took away. So this is 4 in this column, plus 4 more, plus 4 more, plus 4 more. 4 and 4 makes 8. 4 and 4 makes 8. I know 8 plus 8 is 16. So there are 16 squares now. All right. So this is how you would do your work today, and be really careful when you're adding on or taking away columns and rows, and make sure you know the difference. Rows, side to side, columns, up and down. All right, good luck today. You got this.